How does this graph relate to your life? This graph shows how big your problems get if you leave them unattended for long. Leave them for a few days, not that big of a deal. Leave them for long enough and you might be a prime contestant for a F around and find out. No, not really, this graph is just this. But in an effort to try to take some load off of yourself and to avoid your problems spiraling into insanity, let's discuss all the integration techniques today. A-level maths edition. So integration can be split into three main categories: the integration by parts, integration by substitution, and integration by partial fractions. I have avoided throwing in integration by reverse chain rule because I think it is useless, and integration by substitution does what integration by reverse chain rule does, but better. So the first bit is integration by parts, and the integration by parts is traditionally done by this equation, but I find it to be confusing and not really intuitive. So instead, I use the DI method. Now, I'm not going to say that I invented this method, because I didn't. However, it helped me in university for solving this abomination. If you know, you know. Integration by parts is very easy as a concept. You pick one of the two functions which differentiates to 0, and the other function you just integrate. So in a situation such as this one, the function that we were looking at before, you have x squared and sine x. You pick x squared to differentiate and sine x to integrate. Then you put them like this and you differentiate the x squared until it gets to 0. And you integrate the other function however many times needed to match the other one. Okay, then you put plus minus plus minus plus minus here, and then you chain them diagonally, and boom! Integration by parts is finished. Yep, it really is that simple. Now, obviously, if you need me to go more in depth, leave some suggestions in the comments. Next thing is integration by substitution. Integration by substitution is done when you have two functions and one of them is the derivative of the other. Such examples include sine x cubed and cos x multiplied together. Another one is tan x and sec squared x. And another example being this one. I don't know what I wrote here, but I'm sure that I wrote a function which one is the differential of the other. Just so you understand a few concepts. So what do? You pick one of the functions, and usually it's the more complex one. So for example, in the case of sine cubed x cos x, you're just going to take the sine x and make it into u. Okay, then you differentiate the u function and you get du by dx. You then make the dx the subject and swap it back with the original dx. And you will notice that your two functions will cancel out, leaving you with just u, which you can integrate very easily. Boom, second technique, done. Moving on to the last bit. Integration by partial fractions is something that I coined. And the reason for it is because all you really do is turn your fraction into partial fractions like this, and at the end of your job, you just want to put ln of whatever function you have on the bottom. That's quite literally it. The only thing that I would be a little bit wary is if within the brackets of your partial fractions, you have something like 3x, 2x, 5x, something akin to that. Because then you have to do it by integration by substitution, just as an idea. Okay, so there you go. Instead of avoiding this problem, you now have a slightly reduced problem. Follow me for more reduced problems.